In this video, we're going to determine if data is skewed. Now, before we begin with an example, I want to start by showing you a little trick for how I determine which is left skewed and which is right skewed. So as you can see here, I have drawn this kind of creepy little picture, but what it is supposed to be is a set of hands. So you can take your hands, place them in front of you, kind of looking, right in front of your face, palms facing you, kind of just like I showed there in my picture. These are your thumbs. This is your right hand. This is your left hand. Basically, this trick is, okay, now remove your right hand, put it down, and what's left now is just your left hand. And your left hand shows a left skew. So it has a hump and then it has a tail to the left. So the tail on the left on your left hand is an example of what a left skewed distribution looks like. Now switch your hands. So now put only your right hand up facing in front of you. Now your right hand shows you what a right skewed distribution looks like. Has most of its data here, and then the tail is on the right side, or your thumb, which acts as the tail. So just a fun little trick so that if you're taking an exam, you can whip out your hands and remember which is left and right skewed. So it's really all about where the tail is of the distribution. So for example, here's a left skewed graph because the tail is on the left. Here's a right skewed graph because the tail is on the right. And then of course we always have the option that data is symmetrical, which means it has the majority of the data right there in the middle. And so theoretically we can draw a line down the middle and we can have mirror images on both sides. So let's try to apply this. Here's our example. Given the following box and whiskers plots, label the following distributions as left skew, right skew, or symmetric. Okay, so we were seeing them in histograms above, now we're seeing them in box plots or box and whisker plots. So we can kind of see, which pieces of information are on here. So we have, just to remind you, we have the minimum, we have the maximum, Q1, which is the median of the first half. We have Q3, which is the median of the second half, and then that dotted line is the median. Okay, so the middle of the data. Now this tells me, since there's kind of this long line all the way in right here to get to our maximum, that tells me that that creates a tail. So there's a lot of data right here, kind of centered on this side, and then there's a tail. So if I were to draw this as a normal distribution or kind of a curve plot, that's what it would look like. So this represents the tail. So if the tail's on the right side, this would be a right skew. Kind of opposite over here. So we have the bulk of our data here on the right, and then it kind of tapers off to the left. So we have our tail on the left, which is a left skew. And then the last one here looks like there are even tails, and then the data is centered in the middle there. So we call that symmetric.